Thank you for joining this new lecture in this new session. In this session, we are going to talk about a famous attack that is well known in the blockchain space, and it's called the Reentrancy Attack. So we're going to see the theory, and we're going to see the practice, how this kind of attack can be performed on smart contract. This is actually a real world attack that happened in 2016 in the DAO attack, okay, where all the funds were removed from the DAO. So you have to take it seriously. You have to take this attack into consideration, and we're going to talk about how we can prevent this kind of attack from happening in real world smart contracts. So with that being said, let's get it started. So now we still have our bank, okay, power smart contract or power by smart contract. So this is a smart contract, okay, and we have investors, okay. The logic is actually that people are going to put money, or investors are going to put money into the bank, and an attacker is going to remove all the money that has been put into that bank, into that smart contract, so that there's no money left in that smart contract anymore. So the hacker is going to have all the money that has been put into that smart contract. So this is actually the goal of that attack. So really important to understand. So pay attention exactly, and you understand it. So now we have Paul and Laura, or Laura and Paul. So Laura is going to deposit 1 ETH into that smart contract, into that bank, and Paul is going to deposit 2 ETH. So the total value of that bank is actually 3 ETH, okay? This is the total value locked in that bank. And we have another guy, okay, who is a hacker and is going to put also some money into that bank. So we have Paul money that is 2 ETH, we have Laura money that is actually 1 ETH, and this hacker is going to create, his smart contract, is going to fund his smart contract, and with this smart contract is going to deposit 5 ETH, as you can see here, so that the total value lock is actually now 8 Ether, okay, or 8 ETH. This is the total value locked into this bank, okay? And this hacker is going to create a smart contract, as I said. So I told you in the beginning that smart contract can interact each other. So this hacker is going to form a smart contract that is created, or that he has created, and it's going to be a malicious contract, okay, that is going to wipe up all the money that's actually inside that bank. So let's see the next image. So this is actually the hacker, okay. What is going to happen is that it's going to use this malicious smart contract to deposit 5 ETH, as we saw, and since that smart contract is a malicious one, it's going to code, a malicious function inside a smart contract, so that if this smart contract logic is going to tell this smart contract that removes all the money that is inside that smart contract until there's no money left, or there's zero money or 0 ETH left. So to be able to remove, all the money from that smart contract, the hacker must at least deposit 1 ETH, at least. But in this case, the hacker is going to deposit 5 ETH, okay? So if the hacker does not deposit 5 ETH or 1 ETH, since it's actually the least amount he has to deposit, he cannot withdraw all the other, the other amount that has been deposited from Paul and Laura. So this is actually the condition. That is why he created the smart contract. He founded the smart contract with 5 ETH, and he used that smart contract that has a malicious, code to fund this bank. Okay, and the logic of this smart contract is saying that remove all the money from this bank until there's 0 ETH left. Okay, so the condition is that he has to deposit at least 1 ETH. So he's going to deposit 5. And immediately he deposits that 5 ETH, is going to withdraw that 5 ETH. But it's also going to withdraw that 2 ETH, and it's going to withdraw that 1 ETH. So at the end of the day, this hacker is going to have 8 ETH. So there's 0 money or 0 ETH left in this smart contract. So this is actually the principle of reentrancy attack. We have an attacker here and we have investors here. The goal of the hacker is to remove all the money from this smart contract, but to do so, he has to deposit at least 1 ETH. But in this case, he has deposited 5 ETH. So he created, a malicious smart contract, and the logic that is actually lying into that malicious smart contract is saying that remove all the money from this smart contract so that there's 0 money left inside, and is going to deposit that 5 ETH. Immediately is going to remove that 5 ETH. Is going to remove that 2 ETH from Paul and that 1 ETH from Laura. So this is actually how a reentrancy attack works, and I hope it was clear. Now we're going to move to the practical, and we're going to see how to prevent this kind of attack from happening in real world scenario. So we have many types of reentrancy attack. We have cross function reentrancy attack, we have simple function reentrancy attack, and we have others. So we're going to see it in the next lecture. So thank you for joining, and see you in the next lecture where I'm going to talk about the practical part of it. So nice day. Yeah, thank you for joining this new lecture and this new session. In this session, we are going to talk about reentrancy vulnerabilities from a technical perspective. We're going to see exactly how to perform this kind of attack from a smart contract, but also how we can prevent this attack from happening. And in the previous lecture, we saw exactly how we can carry out this, but it was more theoretically. But now we're going to see the practice. And to do that, we need to create, first of all, the smart contract based bank, and then we're going to create, a hacker smart contract that's going to hack that, bank to withdraw all the funds that has been deposited in it. So to do that, we need to create a new file. Okay, we come here and create new file. So we click on that. We say bank.sol, and then you click enter. So it's going to create this file, and it's going to give us the possibility to write our code inside here. So now we need to specify the license. You can type XP, and once you type XP, it's going to show you XPDX license identifier. So you need to click on that, and it's going to tell you this is the license we're going to use, the MIT license. And now the second thing we need to do is to define the version of the Solidity programming language that we're going to use. And to do that, we need to pragma, okay, Solidity 0.8.17. Okay, so this is actually the version of Solidity that we are going to use. We need to know that Solidity programming language uses multiple versions. So as time goes, they release new versions, and each version is an improvement from the previous version that has been used. So it's really important to understand that. Now we need to declare our smart contract, declare the name of our smart contract. To do that, we say contract, the keyword contract, and then we say bank. Okay. So open and close curly braces, and this is done. Boom. We have our smart contract declared, and this is the name of our smart contract. Okay. To do that, we call the keyword contract and give the name. So now we need to create a function. Okay. A function that is going to help us, deposit money into the bank. And it's going to be a special data type that we call mapping. And to understand what I'm going to do right now, we need to understand this illustration I'm going to put here. Okay, you need to understand this. Let's copy it and come here and paste it. So this is what we are going to program right now. Paul has an address. This is Paul, okay? And Paul's connect to the blockchain or to the bank via this specific address. And Paul deposit the money he wants via this address, and this amount of money is actually 2 ETH. This is actually the same for Laura. Laura connects to the bank via an address, and she used that address to deposit this amount of money. This is actually 3 ETH. And this is the same for Bob. Bob connects to the blockchain and connects to the particular bank smart contract via this address. And it deposits some money via this address, this amount of money. So once you are going to program the mapping, we are going to say that, okay, we are going to copy this address, for example, we are going to paste it inside the mapping, and it's going to return this amount. So each time you're going to type this particular address, it's going to say, okay, this address actually has deposit 5 Ether. If you type the Paul address inside the mapping, it's going to say, okay, Paul actually deposited 2 Ether. So the mapping actually, what the mapping actually does, it maps the address of the investor to the amount of money that investor actually deposited. So I hope that you understand exactly how it works. So we are going to program now this mapping so that we can actually see exactly how it works. So I want to go step by step. Let's say mapping. This is the keyword, and now we need to declare the key. It's going to be an address, and this address is going to map to a uint, unsigned integer. Okay, and now we need to specify the visibility of this mapping. Let's say public. We want everyone to see this mapping. Okay, and we're going to give the name to this mapping. We're going to say balances. Balances because it's going to take in charge the balance of all the investors. So once you click on that, mapping, what you're going to see what we just, mentioned or we just explained here. So now we need to put a semicolon. So this is actually how it works, and we are going to see how it works in practice. Now what we need to do is to create a function that's going to help us deposit money inside this bank or inside this mapping. Now we need to say function, let's say deposit, and we are going to give, a visibility to this function. We say public because we want everyone to be able to put money inside that smart contract, okay, inside that bank. And now what we need to do is to call the keyword payable because this function is going to receive ethers, is going to receive money. So each function that receives money should carry the word payable. And you need to understand that if you don't put the word payable, this function will not be able to receive money or to handle that ETH. Now we need to do is that you need to open and close curly braces, and we need to complete our function, our deposit function. So what do we need now? We need to call the mapping, this balances mapping. Okay, so because when you are going to deposit money, is going to be located to the mapping, so we need to call that. Let's say balances. Okay, we call the msg dot sender. msg.sender is actually the address calling this function. Okay, so once an address like this address is going to connect to the bank, is going to press the deposit button, this msg.sender represent any address here that is going to put the money inside this bank contract. So it's going to be plus equal msg.value, and we put a semicolon. msg.value here represents the amount of money or amount of ether that's going to be deposited inside this balance mapping, and it's going to be done by this address. As you can see here, the msg.sender represents the address that is here, and the msg.value represent this value here. There's actually ethers. These balances represent the mapping where all these things are going to be put, like the address and the amount. So it is actually plus equal because you are adding a value to this particular mapping. So it's really important to understand that. Now that we've said that, we need to create another function, and we're going to move, or we're going to try to test this smart contract first. So let's go and deploy it so that you can see how it works. So we come here and we are on this address, this account. Okay, we stay on this account. Now we're going to do is that we're going to deploy. We're going to click deploy. When we deploy, we saw that the transaction has been successfully processed. You can see this tick, this green tick. Now we need to open and see exactly how it works. So we have the function deposit and the function balance. You can come here and see. This is a function deposit. Okay, this is here. So once an address is going to click that deposit button, what's going to happen is that the money is going to go through inside this bank via the balances mapping. Okay, and this is actually the balances mapping here. So we are going to try to deposit some money, some amount of money. So we are here on this account. We choose the first account, and once we choose the first account, we come down, we come to value, and we're going to put, let's say 2, and we want to deposit. We come here, we choose ether. Okay, once it is done, you need to click on deposit, and we are going to see what's going to happen. Click. Okay, so the transaction has been processed successfully. So now we need to check if this address actually deposited 2 ETH inside this bank smart contract, and we're going to use this balance, and this is here. We need to come here, okay, inside account. Since we are on the first account, this first account, okay, we need to copy account to clipboard. Once it is done, you come back here, you position yourself here at balances, and you click Control V. Once it is done, you click over balances. You can see that these addresses actually deposited to Ether. Okay, and now it is in way. So one way is 10 to the power 18, 10 to the power 18 ethers. So let's say one way is equal to 10 to the power 18. Okay, so this is actually how it works. Now we saw that this address actually has 2 ether in it. Okay, we can come here to see what we were actually explaining. Okay, if we want another address to deposit some money, we come to this one, to this address, the second one, we position ourselves here. Okay, we come back here, we say we want this address deposit how much? Let's say 3 ether. And then we come down, we click the button deposit. You see the transaction has been successfully processed. Now to check that this address actually deposit exactly those 3 ETH, we need to come to the balance. But first of all, we need to remove what has been here. So we're going to remove what has been inside here. And we're going to take this address. Okay, we're going to copy account to clipboard. So you make sure that it's actually the second address. Okay, clipboard, copy it, we come here and we say Control V. When we say Control V, we click on balance. You see 3 ether. So this second address actually deposited 3 ethers. So you see actually how it works. So we're going to go step by step for you to be able to understand it right now. So thank you for joining this session, and see you in the next one where we are going to create another functions. Yeah, thank you for joining. Now we're going to continue writing our Solidity smart contract, our bank smart contract. Now we explained and saw exactly how these things work. Now we need to program another function, and this function is going to help us remove the money from the bank, so that once an investor is going to click that button like this, it's going to remove the money that is deposited before. So to do that, we need to create a function for that. Let's say function, let's say remove, this is the name of the function, and we want that function to be public, and we open and close curly braces. So this is actually the function that has been created. Now we need to populate that function to, or create the logic of that function. So now to do that, we need to create a local variable. Let's say uint amount. Let's say amount, okay, is equal to what? It's equal to balances msg dot sender, and we put semicolon. So pay attention to that. This amount is going to balances msg.sender. msg.sender is actually the address who wants to remove the money, or the address who is actually calling that function. And to get that amount, we've said that all the amount that is going to be deposited into the smart contract is going to be located to the mapping called balances. So it's actually all these amounts are going to be, deposited as we explained here. And each amount will have an address. Okay, you can see this is the address, this is the amount, and this is where these amount and addresses are located. So it's really important to understand that. Now we need to make sure that this msg.sender that represent the address of any investor willing to remove, the money, or calling that function, we need to make sure that the amount of money that he really wants to remove exists, in this, smart contract. So to do that, we need to say require, okay, we're going to say amount is strictly greater than 0. If not enough fun. So this is the message, and you put a semicolon. So this is actually the message that's going to pop up if it tries to remove something that hasn't actually put. So before calling it function, you need to have some money inside this smart contract. And if you do not have any money inside this smart contract, this is the message that is going to pop up, not enough fund. So if you deposited like 2 ETH and you want to withdraw 3 ETH, is not going to be possible. This message is going to pop up. So this is actually a message that helps you, specify that, you do not have enough fund. So now we need to program, another line that is going to use to transfer, that amount of money to that, investor willing to remove his money. So now we're going to say that, let's say, I'm going to say bool send is equal to what? Is equal to msg.sender.call. We open and close curly braces. We say value and we say amount. And now we put this parenthesis and we put this one here, we put semicolon. So let me explain exactly how it works. Now we have another line. This line is going to transfer, the money to the person calling this function. So it's going to transfer the money or the ETH to the address clicking on that remove button. It's really important to understand that. So we have this amount, okay? Now we have the call function and we also have msg.sender. So we already know that. Let's come here and explain step by step. This is actually the address. This is the way to transfer the money, okay? Transfer. And this is actually the money. So msg.sender is the address who is going to click on that button and call. This call is a way to transfer, this, amount of money to this address. So this amount of money here will be transferred to someone or the person who is actually calling the remove function. So this is actually how it works. I'm going to see how it works, practically. Now we need to continue. Now we need to make sure that the transaction was successful. We're going to say that require. Now we're going to say send. If not send, we're going to say an error occur. Please try again. And we put the semicolon. So this is actually what we need to understand right now. This is actually to make sure that the transfer has been successful. If the transfer has been successful, it's going to say send. But if it is not successful, this is the message that's going to pop up. So it's going to be an error occur, please try again. And yeah, this is actually how it works. And you put a semicolon. I'm going to put down the code, the whole code at the end. So now we need to create another function to update the balance of the investor, so that once you remove everything, if we want to check again, like in the mapping, we're going to see there's nothing left inside this smart contract. So to do that, we need to call the balance, okay? The balances, the mapping. Let's say balances, okay? Balances of msg.sender. The address was actually calling that remove function, msg.sender is equal to 0. And we put the semicolon. So this is actually an updated balance. So we actually updated the balance of the smart contract. So just a brief recap. This remove function allows you to remove the money from this contract. And we created a local variable that is called amount, and this amount represents the money that the investor is going to remove once he clicks over this button, because each function is going to appear like a button. Okay, and to access that fund, you need to pass through the balance. Balance is this mapping where we have addresses from one side and we have also amount from the other side. So now we need to make sure that this address calling the remove function or pressing that button actually has an amount of money inside that bank. If not, we're going to say not enough fund, because you cannot deposit 2 ETH and try to remove 5 Ether. No, doesn't work like that. So now we continue by transferring that value, okay, that amount of money to that specific address by using the msg.call, okay, value this amount. And this is actually how we write it down. And after that, we make sure that the transaction or the transfer has been successful. So once it is done, we need to check that, need to update the balance of this investor so that his balance should be 0, okay, because he removed everything. So regarding this line, you need to understand that there are 3 ways to transferring, value in Solidity. We have the .call, we have the send, and we also have the transfer. So here we use the .call, but there's also send and transfer that are used to be able to send some money into the value into the Solidity programming language. So now we are going to remove this one because we already worked as we did. And we are going to create another function, a last one, to see the total value that is actually inside the bank smart contract. Okay, let's say function, let's say total, okay, value lock, and we open and close curly braces. We give the visibility, let's say public view. We are going to say returns and uint, because what is going to return, it's actually the amount of, it's going to be the amount of the total value lock inside this smart contract is going to be an Ether amount, okay? So that's we call a uint sign integer. It's not negative, it's positive. So now we need to continue. We're going to say return address. We say this dot balance. So once you are going to click that function, total value log is going to give all the money that has been put, inside this smart contract. So now we are going to test this smart contract. So we come here in this environment, we're going to deploy again. So let's say we come here and we position ourselves in the first address. We come down, we click deploy. You can see that the transaction has been done successfully. So now we come down here, we open this instance. We can see that we have the deposit button, we have the remove button, we have the total value log button, and also the balance button that represent our mapping. So we already know how it works. So now we're going to try to put the money and remove that money too. So let's say we come here, this is the first address, and we stay on that. We are going to put, let's say 3 ETH. Okay, now we are going to go down and click deposit. So the transaction has been successfully done. So this first address actually put 3 ETH inside this smart contract. Let's verify it. You copy this one, copy account to clipboard. Once it's done, we come here at this bank balances, we say Control V, and we click on that. You see there's 3 ethers. Okay, so it's true. Now we are going to remove our ethers. Okay, so we are going to click remove here. Okay, if we click remove, the money that is put is going to go away. It's going to come back in his wallet. Okay, and now we need to add another address into this smart contract. So let's come here, and we are going to make another deposit from this second address. Okay, so this second address is going to deposit 4 Ether. Okay, we come down and we click deposit. So we are going to check it. So you come here, we say copy account clipboard. We make sure that it's actually the second address. Come down, we remove these things or this address. Now we are going to paste the second address that we just copied. Okay, we say Control V and we click on balance. It's going to say 4. So the first address that is actually here deposited 3 ETH, and the second address are actually deposited 4 Ethers. So now we need to remove. We are going to remove. So we are going to position ourselves here, okay, in the first address and try to remove. Okay, once you do that, what is going to happen is that we are going to click on remove. And if we click on remove, we're going to see the transaction has been done successfully. Now we need to come again and copy this address. Okay, we make sure that we are in the first address, and to see what is actually inside this smart contract, inside this address wallet in this bank. So we come here and we remove it. We say Control V and we click balance. We're going to see 0. Okay, so this address has 0 money inside because it just removed it. So if we click the total value log now, it's going to be 4 Ethers because 1 Ether has been, 2 Ether has been withdrawn. Now it is really important to understand that. So we are going to program in the next video the attacker contract to be able to withdraw all the funds from these bank smart contracts. So thank you for joining and see you in the next one. Yeah, welcome to this new section. Now we're going to continue and finish with the reentrancy vulnerability attack. So we already talked about that in the previous lecture. Now we need to create our hacker smart contract that's going to remove the funds from the bank smart contract. So let's come here. We already programmed this smart contract and we know how it works. Now we're going to create another contract. And the contract we're going to create is the hacker smart contract. So we need to come here and create a new file. Let's say hacker.sol. Once we create the hacker.sol file, we need to populate this one. Okay. Now, first of all, we need to specify the license we're going to use and the version of Solidity programming language. Let's say Pragma. And then we're going to remove this one and we're going to specify that version here. So it's going to be 0.8.17. Now we need to declare the name of our smart contract. So it's going to be hacker. Let's say contract. Let's say hacker. This is the name of our smart contract. I'm going to open and close curly braces. And now we are going to create our smart contract, our logic. Okay, we're going to write our hacker smart contract that will help to steal funds from this bank. Okay, So now what we need to do is to create a connection. Okay, to do that, we need to create a connection. We need to create a connection with the hacker contract to the bank smart contract. Okay, and to create that connection, first of all, we need to to create a variable where we are going to put this bank smart contract into. So to create that variable, what we're going to do is that we're going to say bank, and this is the name of our bank. I'm going to say public. We're going to say small bank. Okay, you see the difference. This is a small bank, and this is a real bank that we have. So what are we saying now? We are saying that once we are going to use this small bank, okay, it is going to represent this real bank, because this variable is actually pointing to this bank. So this is a kind of connection, because we are going to reuse this small bank, okay, in the smart contract. But you need to know that this is actually a connection. We have encapsulated this bank that we have here into this small variable. And once we use that variable, this small variable is going to point directly to this bank smart contract. So it's really important to understand that. Now we can see we have an error, and the error is coming from the fact that we need to import this bank to be able to interact with that. So we need to import, let's say import, and we click on this, let's say that's all, and we click put semicolon. So we have successfully imported this bank.sol, so we can actually interact with this, with this bank. Okay, so this is the first connection that we need to do before thinking about hacking this bank contract. So now we need to create a constructor. Okay, let's say constructor, open and close it, and now we need to put a parameter into this constructor. Okay, a constructor is a special function that runs only once. Okay, and it runs at the beginning when we deploy the smart contract, and it is this constructor function that would link the two contracts, the bank contract and the hacker contract. So you need to pay attention on that. Once we are going to deploy this bank, okay, once we are going to deploy this bank, it's going to have an address, okay, because smart contract have addresses on the blockchain, and we are going to use, or we are going to take this address, and we are going to pass this address here, so that once we're going to deploy this hacker contract, is going to link the two, okay, so that we can easily attack it. So this is actually what we need to understand. So we are going to understand it better when we are going to practice it. So let's say now, let's say put address. And this address, what we're going to put inside is actually, let's say bank, and it's to be an address. It's going to be an address. So what we're going to say that now is going to say this bank is equal to this bank, and we are going to pass this bank address like this, and we are going to close this with a semicolon. So what are you saying now? Like I said, once we're going to deploy the hacker contract, okay, it's going to point to this bank contract, because we are passing the address of this bank contract, and this bank contract is represented via this bank variable, and this bank variable is actually here, this is actually the address of this bank variable. So it is it has created a connection. So it's actually connected. So once we deploy this contract, it's going to link to that contract. So now, with that being said, we need to create a function that is going to attack. And this function is going to be, first of all, deposit the money and then withdraw that money immediately. Okay? So it's really important to understand this function that we're going to handle right now. So let's say function, let's say attack, give a name to our function, and then we are going to say this function is going to be external and payable, because it's going to receive, some Ether. So all the function that receive Ether should be payable. Okay. So now what do we need to do? We need to make sure that to be able to withdraw some money, we need to put at least 1 Ether. So this is a condition. So let's say require, and the condition is going to be msg.value is greater or equal to 1 Ether. So this is the condition that has to be met. Okay. To be able to withdraw the money, you need to have at least 1 Ether. So, or you need to deposit at least 1 Ether. So this is a condition. Now that we set the condition, we need to write the line that's going to help us deposit that money. To do that, we need to call the bank. Okay, this variable, we're going to say bank dot deposit, and then come here, we say value, and the value we want to deposit is going to be 1 Ether. Okay, it's going to be 1 Ether, and we are going to say this bank to, we want to remove. So this is actually the function that is completed. So let me explain exactly how it works. So bank is actually this variable that represents this real bank. Okay, you already see. Now we call the function deposit. This function deposit is coming from this bank. Okay, you can see it here. This is the function deposit. So we call that function deposit by, we deposit the money and then we remove the money. So we have these two functions here. And we can use this function here because we imported this smart contract here. So it's really important to understand that. So what this function is doing, you have to put at least 1 Ether, and then this function is depositing 1 Ether and removing 1 Ether. So as soon as it deposits, it removes immediately. Now we're going to create another function that is going to keep removing all the other Ethers that is actually inside this smart contract. And it's going to be a loop. And to use that loop, you need to implement the fallback function. Okay. Since we need to move faster, we're going to copy and paste it. So this actually the logic that you're going to paste, but need to create a fallback function here first. So need to come here. Okay. So we need to create the fallback function. Fallback function is a function that helps receive money. Okay. So it's going to be external and payable. So we need to open and close those curly braces. So it's actually here we are going to write this logic, and it's going to be a loop. So what the fallback function is going to do? The fallback function is going to do that. You're going to say that if there's money, okay, inside this smart contract, remove it until the contract gets zero money inside. Okay, so you're going to come here because you don't want to waste your time. You're going to copy it. Let's say remove this one. Let's copy it, and now we're going to paste it inside this fallback. So what it is actually doing, if this bank address has a balance greater or equal to 1 Ether, remove this money. Okay, this is actually the logic, and we are going to see how it works. So now we have a small error. I don't know. This contract has a payable function but not receive Ether function. Consider adding the receive Ether function. Okay, so we are going to first of all implement this and try to change to put the receive function that is actually the more updated version of the fallback function. So you can remove it here like this. Receive, and we can remove it like this. Okay, so now the contract compiles well. So we're going to create another function to be able to view the total balance of this hacker. It's a function, or you can come here and copy it since we don't want to lose the time. So you can just do Control V, and it's actually the same function to be able to see the total value lock inside this smart contract. So this is our smart contract ready, and now we are going to test it and see how we can actually hack our bank contract. So see you in the next lecture. Yeah, thank you for joining this end of section for this reentrancy vulnerability attack. So now we are going to implement our reentrancy vulnerabilities attack and see how it works perfectly. So you need to pay attention to that. You need to be, calm down and understand exactly what is going to happen. So we are going to go step by step. So the first thing we need to do is to come to this bank contract, okay? And we need to deploy this contract, okay? So what we're going to do is that we're going to come here, we compile it because we chose the auto compiler, and we come down here at the run and deploy transaction. We position ourselves in this first account, and then we come here now. So this is actually the instance. So we can click deploy easily. So the smart contract has been deployed successfully. You can see the transaction has been confirmed here. So you need to open the instance of this smart contract. And now what we need to do is that we need to deposit some money, okay? We are going to start investing in that smart contract. So now this is the first address, and this first address is going to deposit 2 Ether. Let's say 2, and we select Ether. We come down and we click on deposit. So you can see the balance is 2 ETH. Okay, if you click total value, you're going to see 2 ETH. This is the total value that is inside this smart contract. So we are going to choose the second address, and the second address is going to deposit 3 Ether. Okay, this is the second investor. So we choose 3, and then it's already at Ether. So we come down and we click deposit. So you can see the total value log now is 5. If we click total value log, we're going to see 5 Ether. So now this contract is working perfectly. Now we need to check if the hacker contract also works perfectly to be able to hack these 5 contracts, these 5 Ethers. So what is going to happen when you are going to launch this attack? all the 5 ethers are going to be wiped. Okay, the hacker is going to remove all the 5 so that this contract balance is going to get 0. So we need to check 2 things. Okay, now let's position ourselves in this first address. We copy, and once we copy it, we come down and come here, we say Control V, and we click on balance. So it's 2 ethers. So we already saw this one, so we can move on. So now we need to go and deploy our hacker contract. But to do that, we need to copy the bank address. Okay, this bank smart contract address, because I told you when we were programming this contract that once we are going to deploy this hacker contract, we will need the bank address. Okay, this bank address, and we denoted this bank address with this variable. This bank address represents this variable, and this variable represents this bank contract. So once you're going to put the bank address here, it's going to create a connection, and it is with that connection that we are going to remove the funds. So what we're going to do now is to come down. We're going to come here, and we are going to copy the address, okay, of this smart contract. This is here. Let's come here. Let's copy it. And now we are going to deploy the hacker contract. So this is the instance. So to deploy it, we come and copy the bank address, copy, and we come here, we do Control V, and now we have the address of the bank that is actually inside the constructor, and now we can deploy the hacker contract, and it's going to point directly to the bank contract. So once we click on deploy, you see the transaction has been validated successfully. So now we have created a link to this bank. So let's come here and open the hacker contract instance. So we can see we have 3 buttons. We have the attack button, we have the total value log, and we have the bank, variable that we declare here. So it's really important to understand that. So now, what are you going to do? We are going to launch our attack. So we saw that in this bank, we had 5 ether. The total value log is 5 ethers. So we are going to see, after launching the attack, we're going to try to see if this bank contract still has fund in it. So we need to come over here, and we already used the first and the second address. For the hacker, we are going to select another address. Let's come here and select the last address. So you can see that this last address has 100 ether. Okay, after launching that attack, we're going to see if the amount of money that this address has is still 100 ether. So we are going to select the last address for the hacker. So we are here, and then we are going to come down here, and we are going to say we want to deposit 1 ether, because this is the condition. So it's going to deposit 1 ETH to this contract, and once it deposits that 1 ETH, it's going to remove it, directly, and remove all the other funds that has been deposited. So once we're going to click the attack button, here we are going to see 0. Okay, it's going to remove all that money. So we're going to see if it works as intended. So we're going to click the button. The transaction has been successfully done. Okay, now we need to click here to see the total value. we're going to see the total value is 6 Ether. Okay, the transaction has been mined successfully and the attack has actually worked successfully. So if you come here and click on total value, you're going to see is 0. So we remove all the funds from this smart contract. So this is actually how it works. So now we have the attacker has all the ethers, okay, on his smart contract, and in the bank smart contracts there's no money left. So it has actually wiped out, okay, all the investors' fund. So this is actually how reentrancy attack vulnerabilities work. So you need to understand exactly how it works. So now that we've seen the attack, we need to see how we can mitigate this, okay? So see you in the next section and to talk about mitigation, okay? Yeah, thank you for joining this new lecture. Now we are going to see how to mitigate this kind of attack, okay? We've talked about the reentrancy attack. We saw how to launch it. Now we're going to take a look on how to mitigate them. So we're going to see why, okay, this hacker was successfully able to launch this attack. So it's really important to understand this. And to understand it, you need to understand that smart contract, are sensitive, okay? It is not all about writing smart contract. It is all about writing, secure smart contract. And you need to respect some logic to be able to secure your fund, okay? This is actually something you need to understand as a smart contract developer or a smart contract security auditor or someone willing to have some knowledge about this field, whether you are an investor, a CEO, or someone else. So now we need to see where the vulnerability is actually lying. And I can tell you that this is actually coming from this remove function, okay? It's coming from this remove function. So once an investor tries to remove the funds from the bank, so what is happening? We check first of all that the amount of money that he wants to remove exists, okay, inside the bank. And then we transfer that money directly. And once the money has been transferred to this MSG.sender that represent the investor that really wants to remove his money, now we do the balance updating. And this is actually a wrong way to program smart contract, because once you check that, okay, he wants to remove this amount of money, he has it, now we make a transfer. What may happen is that the hacker or a malicious contract may keep transferring all the money inside that bank smart contract. And once all the money has been removed, the next line is to update the balance. I come again. This is a bad way of writing Solidity language, okay? Because once we check that, okay, he has this amount of money he claims to remove, this function should not come in the first place, because this function is transferring the money to the MSG.sender. And MSG.sender is actually the person calling that function, okay? If it is a malicious contract, it can create a loop to keep transferring the money until this smart contract gets zero money inside. And then we update the balance of the smart contract. So this is actually what has been created here. It has created an if condition. Okay, this is actually the function. If this address has one or equal Ether, remove everything. So this is actually that loop that has been created. So a malicious contract can use this and transfer funds over and over and over. So what we need to do now is to create what we call a checks effect interaction pattern, because this function is checking first of all, and this effect is naturally this balance msg.sender. So we need to update the balance after checking, and after updating the balance, we can transfer the fund. So it's actually a technique that we call checks effect interaction pattern. Let's say, let me write it here, check, okay, effect interaction. So this is actually how it works. We have checks, we have the effect, and we have the interaction. So the first function now is checking, and we need the second function that's going to be the effect. So it's going to set the balance to 0. So we update the balance first, put it here. After updating the balance, we need to make some interaction, and the interaction here is going to be with these msg.sender that represent the address of the investor who really want to remove his money. So we need to implement this checks effect interaction pattern, and we need to remove this one, because once this investor is going to remove that money or that malicious contract, we're going to check that he has that money, and once he has that money, we update the balance to 0 because it's actually removing all the money, and then we make a transfer. So now we're going to see exactly if it actually works. So we need to keep it in mind. Checks effect interaction pattern is a way to prevent this Solidity programming language from reentrancy attack or smart contract reentrancy attack. So we also have another one that is called the mutex. The mutex, to use it, we can actually import the Open Zeppelin, smart contract to be able to use the mutex because they implemented in their smart contract. So it's easy to do that. So you just need to import, and yeah, we're going to see that later. Now we need to deploy this smart contract again and see what happened with all the changes that we've done. So we're going to deploy it. Let's come here. Let's position ourselves in the first address. Okay, now we need to deploy. We are going to click deploy. Okay, the contract has been deployed successfully. Now we are going to deposit some money inside. Let's say 3 Ether. Okay, if we click here, deposit, you're going to see that there's 3 ETH in this contract. So the contract has 3 ETH. So now we are going to deploy our hacker contract as well and try to launch this attack again to see if it's going to work. So now we have this one. What do? We need to copy this bank address. Okay, and come here, say Control V to paste, and then we position ourselves into the last address. So the last address represents the hacker. So this hacker is going to deploy, okay, the contract. So the contract has been deployed, and now we're going to open this and see this function. So we have the attack function, we have the bank function, and we have the total value. So now we are going to click on attack and see if we can withdraw all the funds from this contract, okay, from this bank contract. So what we need to do now is to try to deposit some money and try to remove it. So it's going to deposit 1 Ether. So what's going to happen is that we are going to come down here and we are going to click attack to see if it works. Now we're going to say click attack, boom. We're going to check if the vulnerabilities is still here. So we can see that, okay, the transaction were not successful, okay? And if we click on total value lock, we can see this hacker contract has 0 money inside. So the transaction were not successfully and the attacker were not successful in launching this attack. So the reentrancy attack didn't work because we updated this value, okay? We updated this syntax in this code with the checks effect interaction pattern. So if you come here and check the total value log, you're going to see it's still 3 Ether. So nothing has changed from this smart contract. So thank you for listening to me, and see you in the next vulnerabilities where we are going to talk in depth for you to understand. So I really want you to understand how things work. So that's why I take time to explain step by step. So thank you for joining once more, and see you in the next section when we're going to talk about other vulnerabilities.